How do you analyze a circuit using KVL, also known as Kirchoff's voltage law? Find out right now. Hi, I'm Dr. Matt. There are no lectures here. I just solve problems, homework problems to help you understand how to do them. Electrical engineering at your service. In this problem, we have several sources. We have a plus and minus 120 volts. So we have a fixed power supply here. We have a dependent power supply here, and this is going to be plus, minus, and that's going to be 20 I2. And then we have another dependent voltage source, and that will be 3 times I1. And then we have a dependent current source, which is also 3 I1, but instead of current it's voltage, so plus, minus, and then the current going this way. And then we have another independent power supply from minus plus, and that one will be 12 volts. Okay, and then we have our ground here, and then we have a resistor here, and another resistor here. Call this R1, R2. R1 is 5 ohms, R2 is 8 ohms. And then we have a voltage at this node V1 on this leg, actually this branch, and another voltage V2 on this branch right here. So we also have some currents. This is I1, I2, and then this would be I3, and then of course we'll figure out what some of these currents are. So how do we solve this problem? What we're going to do is, there's nothing that's obvious right away that we can do with this, so we're going to have to use either KVL or KCL. And if you don't know what KVL and KCL are, look up my KVL video. Okay, so in the KVL, we're going to add up all the current, all the voltages in this loop, and they should add up to 0. I'll call this loop A, and I'll call this loop B. I'm going to make it clockwise loops, and then I'll call this loop C. So for loop A, let's do that one first. We have from minus to plus, that's going to be plus 120 volts. And then here we have from plus to minus, so it's going to be minus, that's a voltage source, 20 times I2. And then in this last part of this voltage loop, we have minus I1 times 5 ohms. All of those add up to 0. Okay, so that's loop A. Let's do loop B. Loop B, we're going from minus to plus, so we're adding plus. Remember, current goes from positive to negative, but if you're going from negative voltage to positive, it's a rise in voltage. If you're going from positive to negative, it's a fall, so you subtract it. Okay, so plus 5 ohms times I1, and then this is from positive to negative, so it's minus 3 times I1. Did I do it? Yep. And then the last one is I2 times minus 8 I2. And all of those add up to 0. Okay, so that's loop A and B. The third loop, we don't know the voltage here. We know this is point right here. V3, if you want to call it that, is minus 12 volts. But we don't really know what the voltage drop across this is, so we can't make up a third loop. What we can do is we have 5I1 minus 3I1 and 8I2 equal to 0, which is going to make it real easy to solve for I1. So 5I1 minus 3I1 is 2I1 equals to 8I2, or I1 equals to 4I2. So there's our first identity. The next thing is we plug that back into here. So let's do that. Let's plug, so we go back to loop A, and it's 120 volts minus 20 times I2 minus 5 times I1, which is 4I2, and that equals to 0. So a little bit of simple algebra here. 20 plus minus 20 is minus 40, or 120 volts is equal to 40 times I2, or I2 is equal to 3 amps. Okay, so that solves I2, and that gives us this first little piece right here. This is I2 over here. It's 3 amps, right? And then I1 is 4 times that, which means that I1 is equal to 12 amps. Okay, so most of this problem solved already. 12 amps. Now we can use this to find V1 and V2 right away, right? V1 is, since this is 0 at this whole leg here is all 0, right? Right up to these points here. This whole branch is all 0. So 12 amps times 5 ohms, V1 is equal to I1 times R1, which is equal to 12 amps times 5 ohms, which is equal to 60 volts. And then of course V2 is just as easily solved, is equal to 3 amps times 8 ohms. Okay, and that is equal to 24 volts. Okay, so now we have V1 and V2. V1 is 60 volts, V2 is 24 volts. We've almost got this problem solved. But we do have the problem almost entirely solved. But let's verify that our numbers make sense. So we have here, this voltage is 20 I2. We know that I2, let's see, V1 is, let's write these down, V1 equals 60 volts, part of our solution. V2 is equal to 24 volts, that's part of our solution. Let's make sure that some of this stuff makes sense. Okay, so 20 times I2 is 3 amps, that's 60 volts. So 60 volts. So here we have 120 volts minus 60 volts equals 60. Well, that's correct. So that one's good. And this one is 24 volts, so there should be a 36 volt drop between V2 and V1. So this should be minus 36 volts. Well, 36 volts in this case is equal to 3 times I1. Well, I1 is 12 amps, which is times 3, which is 36 volts. So that's good. So that works out just fine. Thanks for watching my program. If you like my videos, be sure and subscribe to my YouTube channel. And for an organized listing of my YouTube videos, go to my website, www.wherearemyplacebos.com, and click on videos. Have a great day.